Hi everyone, this is Elixir's most published author, Bruce Tate. In this video, we're going to talk about OTP, the soul of Elixir. This video is an introduction to core concepts. If you want to dive deeper, I invite you to come to Groxio. There you will find video courses and professional training opportunities to get that job or secure the promotion that you've been looking for. Let's go. Hey everybody, it's Bruce and the dog on the floor, and we've been talking about OTP. This is the definition that we've been using. That's the library of processes with a common API for message passing and managing lifecycles. And today we want to focus on the idea of message passing. Specifically, we want to talk about all the different ways that you could send a message to an OTP process. And we want to talk about the inputs and outputs and their impact on the overall state and what the user receives, and the API for using each one of those ideas. Let's get started. Now, we've talked about the idea that a GenServer is a behavior. And remember, that means that we're building a plugin. We're going to leave the process machinery to the GenServer, and then we're going to plug in our specific implementations to handle message passing and initialization behaviors, as well as some monitoring and starting and stopping that will happen in our supervisor. But what that means is that there is a contract, and that contract comes in the form of a behavior that specifies certain callbacks. And remember, after we start a process, the GenServer is in control. So we don't call the callbacks. We leave that to the GenServer so that the GenServer can implement the idea of a message call or starting or stopping the processes. Now, the callbacks that I want to talk about today are the handle call, and that is a two-way bit of communication, the handle cast, and that is a one-way or asynchronous bit of communication, and there's a trapdoor which allows us to send a regular old Elixir message into the GenServer and process that as well. And that's called handle info. So we're going to build a very simple GenServer with a handle call, a handle cast, a handle info, and an init, which is the only required callback. Let's build a mix app. So our brain dead GenServer application is going to do no more than remember a single bit of information, and we can ask for it or we could set a new one. That's it. Let's just call it a remember all. So I'm going to say mix new remember all, and I'm going to go ahead and add the supervisor. And remember, the supervisor is responsible for our lifecycle. Then I'm going to change into that directory, and we'll build our GenServer right there. So let's go ahead and enter the code editor. Okay, here we are. And what I'd like to do is drop right into our implementation, which is going to be in remember all. I don't need anything in here, and this is the only file that we're really going to use. And we're going to essentially have a value that we set or get with this, and then we'll have the three different kinds of callbacks. And so let's go ahead and establish our initial state. And so, by the way, we can go ahead and use the online documentation to tell us what a GenServer looks like. So let's do that now. So now we're in IEX, and I could say H GenServer, or I could say H GenServer dot, and then tab, and then I could see the callbacks. And now remember, from phone call, I'm going to manage the handle call, and that's the other side of this one. The other side of the start link is going to be the init, and so on and so forth. But I really don't care about the functions at this point. I care about the callback. So let's get the documentation on GenServer overall, and let's take a look at what the callbacks that it's recommending are. Okay. And so this is the top level application right here. I was looking for this gold title, and these are the callbacks, two of the three callbacks that we need. One of them is a handle call and one of them is handle cast, and we also need the init. So I'm going to go ahead and grab these three and just drop them into our code base. And I'm going to just drop them into our code base just like that. And let's fix the indentation here. Looks like I grabbed an extra end, which I don't need. Okay, I could use mixed format for that just as well, but I'll go ahead and just play with it that way. And I also need to specify the behavior, but rather than to specify the behavior with the behavior module attribute, what I'll do instead is use GenServer. And this is code that is actually going to write some code. And one of the things that it does is establishes that I want to use the GenServer behavior. And then everywhere that you see an impl true, this is one of the callbacks that we're going to use. And the fourth one that we need is impl true. That means this is an implementation for the callback. That's all it means. So I'm going to do something that looks like a cast, but is an info, right? And so for each one of these, this is a message, and let's call this get, let's call this set, and let's call this say, right? And so the state is, we're just going to use that as a state. So here, all we're going to do is print a message. The value is, and then the state, just like that. And here, what we're going to do is in this case, we want to set the new value. So we want the new value of the GenServer to be value. And in this case, there's a call. We want to get the value. So this is the state. All we want to do is return the state to the user and then just retain the state. And we'll talk about what all these do in a second. And then here is the initial state. We're not going to take the opportunity to transform it. Just the state as it is going to be fine for us. And that's all we need for this, but we can go ahead and make things easier on ourselves by having not just a callback layer, but a client layer, right? So the client layer uses the GenServer APIs. So all of this will execute in the GenServer process, and all of this will execute on the calling process. And on the calling process, we'll use the GenServer and let the GenServer take care of the message passing. And we can't call into this code. We're going to leave that to the GenServer itself. Okay, so we need to be able to start, and we need to be able to set or get, set, and say. And let's build a def for each one of these. And the get, set, and say, these are all going to take a process ID. And let's default that to just mem. And then we won't have to type the whole process ID or capture the ID or anything like that. That'll make things easier to work with when it's time to demo it. And for each one of these, we're going to have a do and an end. And in this case, we're going to send the message get. We're going to say GenServer dot, and this is going to be, so a get is a call. So we're going to do GenServer dot call. And then we're going to have the PID and the get. So that's the name of the message. And the set, we need to tell it which item is the new, or the value that's going to be the new value. So we're going to say GenServer.cast, and then we're going to have the PID, and then the set of the new value. And here we want to combine our message needs an argument. So all we're doing is tying the set and the argument together with the tuple, because I only get one element in that API. And the say is, rather than using GenServer to send the message, I'm going to send a plain old Elixir message. So I can do something like this. I could say, PID or gen, or I could say send the PID, the message say, right? Okay. And so in this case, we'll print the value. In this case, we'll set the value. And then in this case, we'll get the value and it'll be sent back to our process. Yeah, I think that's looking good so far. And then after we take this for a little bit of a spin, what we're going to do is go back over this and talk about what each element of the tuple does and what each argument is going to do for us. And we'll do that next. Okay, so let's code over to our IEX session and we could say recompile. Okay, so we have a compile error. That's okay. Let's see what's happening now. So the implementation is not provided for the predefined def start. Okay, so let's do that. Yeah, so we never did finish this def start. So this is going to take the initial value and we're going to say GenServer.start link. And we have to provide the module that implements this, but rather than typing that module name, we have access to it this way. So that's this module and then the initial value. And then we need to name this thing. We have to give it the name that we specified right here, which is mem. So I'm going to save that much and let's go back to the IEX session. And recompile. Okay, so it says that state is unused in one of the places. Let's see if we could tighten that up a little bit. So that is on remember all 31. Let's go back here and remember all 31. This is the handle cast. So we have the state and we don't use that state, do we? Right? Because what we're doing is we're providing a new state with this one. Okay, so that's good. We can recompile. It looks like, oh, probably didn't save my code. Doesn't matter because all we did was ignore that implementation. Yep, you see the dot there. I didn't save. So we're going to go back into IEX. Okay, so now I can say remember all .start. That should have probably been called start link, and I'm going to go ahead and fix that. Start and start link have different connotations. Start link basically means I'm linking the process back to the caller, and that means I'm going to establish a link that's going to be useful for GenServer in order to monitor this for reliability. And so this name can be anything that I want it to, but it's like a lie if I give it a name of start and not start link. I want to really tell the user that this is linked back to the starting process, my supervisor itself. Okay, so I'm going to do that. And I'm going to recompile again. So yep, that's fine. So I'm going to say remember all .start link, and then all I need to provide is the initial process. And let's just give these colors, right? Red. Okay, and I can do a remember all .get, right? And it's a red, and I could do remember all .set, and I could specify a new color. And then I could do a remember all dot, what was the other one? It was a say. And then it returned say, but it said the value is green. Okay, so what we've got here is a working GenServer that does, all it does is establish a variable, and it's not something that you really want to do in production code. But the idea is that we have process machinery that's wrapping a concept that's nothing more than setting and getting state. And so what I'd like to do for the rest of this session is look at exactly what the elements in the tuples and return tuples do. And we'll do that next. So in this code base, there are shockingly few concepts at work here. So the first concept that I want to talk about is that GenServers have state. And we need to worry about the state as it comes into one of our callbacks. And we get the opportunity to change the state when it goes out of one of our callbacks. I'm going to say this, 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 and this are all the old state. Okay? And I'm going to say that sometimes we convert the old state to the new state, and sometimes we don't, right? In this case, the new state is just the old state. And in this case, the new state is just the old state. And in this case, the new state has already been set and we're ignoring the old state. And in this case, I'm not changing the state either, so the new state is the old state. So the old value is old state. And then what I want to show you here is the power of this tuple is that it can change the state of the GenServer. And in each case, it's the last argument, or it's the last required argument of each type of tuple. Whether you're talking about the tag tuple that comes back from the init, or a reply tuple that comes back from a handle call, or a no reply tuple that comes back from a handle cast or a handle info. And so these all are going to take new state. So GenServers have a state. Whenever we get a callback, we get the old state, and we get the opportunity to set a new state, whether we decide to change it or not. The next thing that I want to talk about is how we think about message passing. All right, so let's put this API aside, the init, and let's talk about the three message passing callbacks. Really, there are two types of callbacks. One that has a reply and two that don't. So handle info is an old style Elixir or Erlang message. We send it with just a simple send. And in fact, you can see that send in play right here. And send is an asynchronous message that doesn't care at all about the reply. What's happening when I have an asynchronous message is GenServer says, okay, I don't have to send anything back to the client, but I do have to give this user the opportunity to establish the new state for the GenServer. So both of these are a asynchronous or one-way message. Said another way, a call without response. Or let's call that a message, just to not be confusing. Okay, so that's the second concept that I want to get across to you. Some Elixir messages don't need a reply, they're asynchronous. And in those cases, they get a no reply tuple. And what do we need to specify? Well, the new state of the GenServer. And then the final concept that I want to talk about is that some of the messages are synchronous messages. And what does that mean? Like a phone call, these are two-way. And these are messages with response. So we could call this state. We could also say we're going to send to client whatever the old state was. Right, so I'm going to label this to client. So if you look at these tuples now, they specify what each part of the argument does. This first atom labels the type of tuple. The last item specifies the new state for the GenServer. And if there is a middle item, this is the response that's returned to the client. And so what we have here is an API that works effectively whether we're sending something back to the client or not. We have a callback. We do whatever our business logic is. We have an opportunity to change the state if we want to with a function or with some intermediate computing. And that could be as simple as saying, leave the state alone, just providing state, or it could be as complicated as set the state to the results of this database query or this internet HTTP request. So what we're left with here is a generic server that allows us to specify our code to provide business logic to do whatever we want to. So said another way, we make the generic server specific by message passing, tracking state, and specifying the initial value upon startup. It's a wonderfully generic API. It's easy to understand what you get, what the underlying behavior is trying to do, and it allows us to separate an important concept, process machinery, from whatever my business logic is. And that, my friends, is an excellent thing. From Bruce and the dog on the floor, this is Groxio Learning.